Alrighty, hi guys. So today and for the next kind of couple of days, we're going to go back to looking at simultaneous equations, which is something that we spent quite a lot of time on, earlier in the year. And and a lot of the stuff that we're going to talk about, we did cover earlier. So we're going to use this mostly as maybe a little bit of time to do some revision and a bit of recapping, and to think about simultaneous equations in more of a graphical way than an algebraic way. So that's what the focus of this little mini topic is. It's all about graphing solutions for equations. So we're going to start off, and there's not going to be really a huge amount of notes. I'm not planning for this particular lesson. So we're going to start off just by looking at how do we solve equations graphically. So I'm just going to chuck in a quadratic here. It's going to be x squared. I will just do a really basic one. We'll go minus x minus 12. Okay, so that gives us x-intercepts at -3 and +4. And we can see we've got f of x there. So I'm just going to chuck this in. And if you want to, feel free, once I've done this video, to go through and actually do this on GeoGebra and have a go and play around with it yourself. You're at home, you've got your computer in front of you. Use the software that you have available. So if we were going to find the intercepts for this at -3 and +4, we would make that equation equal to 0. And what you're doing when you're making the equation equal to 0 is we're really finding where the intersection points are between this equation and our line where that's equal to 0. Now, hang on, that's not working for some reason. Let me just y equals, okay, so there we go. I just type in y equals 0. So we're finding where does that line y equals 0 cross over with our quadratic graph x squared minus x minus 12. Likewise, if we were going to find, say, where does it intersect with, say, -6, if we put in the horizontal line -6, you can see it there, we can see that it intersects at x equals -2 and x equals +3. Okay, so there are our two solutions in that case. And of course, we would solve that by, just give me a second. Right, there we go, I've just snippied in that. So if we were solving for this horizontal, this red line, we know our equation is x squared minus x minus 12. And we're wanting to solve for where that is equal to our y value of -6. Okay, because we are wanting to find where is that the same? Where are we equal to -6? And we would do that obviously then by bringing that -6 onto the other side, making it positive, solving for where that equals to 0 because it is a quadratic. We would then end up with -x minus 6 equals to 0. Now, two numbers that multiply to equal -6, add to equal -1, are of course x plus 2 and x minus 3. Okay, -2 and -3 give you the -1, and 2 and -3 give you the -6. So therefore you have x values at -2 and x equals 3. Okay, so that's what we're doing whenever we're solving for an equation. We're always looking for where does that horizontal line, where does our y value cross with our curve or our straight line or our circle or whatever we're looking at in our equation. Okay, the next thing, I'm just going to pause this, I'm just going to go back to GeoGebra. So whenever you solve an equation, to some degree you are solving a simultaneous equation because you're finding the intersect point between two different equations that you have. It's just one is a constant value. But what happens when it's not a constant value? What happens when you're wanting to find the intersection point with something that it has a variable itself? Well, that's when we end up with what our classic kind of simultaneous equations. So I'm just going to chuck in here g of x equals to, we'll just go straight up with an x. Okay, so if we chuck in that straight line, now we can see that there are two intersection points. They're not great values, but that's fine. But there's one at about, say, about negative 2.7, I reckon that would be about, and there's one at about maybe 4.3, 4-ish, I think, there. Okay, so let's have a go at solving this. So we can put this in. Okay, so we can check this one in here. And if you would like pictures of these graphs as well, send me an email, because I always save everything that I type on the computer. So if you would like that, send it to me, and then you can cut it out and put it, copy and paste it. But I'm happy if you just want to freehand draw it as well. That's completely fine. Okay, so again, our equation was x squared. Oh, that's weird. Why did that happen? X squared minus x. Oh, that's really odd. Okay. Alrighty. Yeah, our equation is x squared. Why? Sorry, guys. I'll sort this out and I'll get back to you. My computer hates me today. Okay, so we've got x squared minus x minus 12, and g of x equals to x. Now we're wanting to find, where does f of x equal to g of x? Where are they the same in terms of their coordinates? So again, what we do when we're solving is we have x squared minus x minus 12 equals to x. Okay, we're then gonna, again, it's still a quadratic, so we still need to solve in the same way. So we're gonna bring that x onto the other side. So we're gonna minus that x. Okay, make that equal to 0. So we end up with x squared minus 2x minus 12. All right, now we can tell, because those weren't nice numbers, I'm just going to jump straight to using quadratic formula, because if they're not whole coordinates, the factors aren't going to be good, they're not going to be easy to work with. So straight away, quadratic formula, negative b plus or minus square root b squared minus 4ac over 2a. Okay, so I'm going to sub that in. So we're going to end up negative 2 is positive 2, plus or minus negative 2 squared is 4, minus 4 times 1 times negative 12 over 2. So then I'm going to end up with, so that's 4. Now 4 times 12 is 48. So that's positive 48 because you've got the two negatives there. So 4 plus 48 is 52 over 2. Okay. And then x will be equal to, now I'm just going to chuck this in my calculator. I should have my screen one up, but I forgot this morning. 2 plus 52 over 2 is, that's 4, x equals 4.6. Okay, and then 2 minus the square root of 52 over 2. Okay, that's negative 2.6. Okay, now to solve then, so this, we know our x coordinates then here are 4.6 and negative 2.6. Okay, we then need to solve for our y coordinates of the graph. So I'm going to use, much easier than using the quadratic, I'm going to use g of x equals to x. I'm going to say g of 4.6 is equal to, surprisingly, 4.6, because your x coordinate and your y coordinate is the same. So that's 4.6 there. And then g of negative 2.6 is negative 2.6. And that's that coordinate there. Beautiful. So there are your 2 points. That's where they cross over each other and they're the same. Just give me 1 second. I'm going to get GeoGebra back up again. So again, like we talked about earlier in the year, I just wanted to emphasize as well that there are different kinds of solutions that you can have, especially when you're looking at a curved graph intersecting with like either another curved graph or a straight line graph. So obviously in this one we can see that we've got 2 points of intersection here, one at this coordinate and one at this coordinate. If I change the equation of this graph though, and I said I'm going to make this minus 18, okay, we can see now in this case there's no coordinates, no points of intersection, and there never will be, because this one's going to keep increasing super steeply, whereas that straight line graph has a much slower gradient, so they're never going to cross over each other. So in this case, when you did the, if you tried to find the intercepts between them, and I'll show you quickly on my calculator, Smart View. I'm just going to type in Smart View. Okay, so on my calculator, so x minus 18, so if I brought that across on the other side, we'd end up with x squared minus 2x plus 6, because you'd be adding 18 to that negative 12. So if I put this in, just have to wait for this to get started. Sorry, I should have done this earlier. Alrighty, so if I use my quadratic formula app, number 9, number 1, okay, so I've got, so that's me 1x squared minus 2x, okay, and that's me plus 6 on the end there. Okay, so that's perfect at the moment. So if I now solve this, you can see there's no solutions, no real roots. So that's like a math error. So no solutions. So these lines will not intersect with each other at all. Okay. Last one I want to show you is, I'm just going to try and do this a little bit by trial and error. So I'm going to go minus 13 here. Okay, perfect. That looks like it's about right. Okay, so now hopefully I'm quite impressed with myself about that. Well done. Okay, so if I'm now going to take another screenshot. Now with this, you can see that this line, and hopefully when I actually work this out, it's going to confirm this. That line doesn't actually go through the graph, but it does touch it. So there is a point of intersection. But there's only one point of intersection. So if we now solve for this one, and we take our original quadratic, x squared minus x minus 12, and g of x, which is x minus 13, and we make, again, f of x equal to g of x. I always like writing this as well, by the way. I think you should, and I think that really emphasizes the fact that you're finding a point of intersection. So you get x squared minus x minus 12 equals x minus 13, and again we're going to want to take away x and add 13. Okay, we're going to end up with x squared minus 2x plus 1 equals to 0. Now, two things that multiply to make positive 1 and add to make negative 2 is negative 1 times negative 1 and negative 1 plus negative 1. Okay, so we have x minus 1 equals to 0, which is the same as x minus 1 all squared equals to 0. Okay, which is the same as then x equals to positive 1, because you end up with your, sorry, I won't skip a step, I'll do it all properly. We end up with x minus 1 equals to 0, so therefore x equals positive 1. Okay, then you would go through, sub in 1 probably into g of x, make it nice and easy, and we end up with 1 minus x, which is negative 12. 1 minus 13, sorry, which is negative 12. So therefore your point of intersection is at positive 1, negative 12. And that's that point there. Now this is what we call a tangent to the curve, because it doesn't intersect the curve, it touches it and then keeps going. Alrighty, so there's a little bit of a sheet for you to do once you have got that, and then yeah, that's pretty much it for this morning. Okay, alright, bye.